Okay, now let us take a look at what we actually did in the end of this exercise. We said no matter which omega we choose, then an multiplied by x of that omega will always tend to 0. And that means that the set for which an multiplied by x tends towards to 0 is the entire probability space. Now, if you say that to yourself like 2 or 3 times, you may probably convince yourself that it's true. It definitely seems pretty true. But let us try to write down exactly what's going on to understand the logic behind it. Okay, so no matter which omega we choose in omega, we will always have this. This means that if omega lies inside the probability space, then it implies that an multiplied by x of omega tends towards 0 as n tends towards infinity. There is a correspondence between implications and set relations. And that correspondence is this. What this actually means is if omega lies inside this set, then omega also lies inside the set for which an multiplied by x of omega goes towards 0, right? So that actually means that the set over here that omega lies in, well, as long as you choose something inside this set, then it will also lie inside this set where an multiplied by x of omega goes towards 0. So what we actually mean by this is that the probability space is inside here, and everything that you choose in the probability space lies inside a bigger set, namely the set for which an multiplied by x of omega goes towards 0. Yes, so actually, to be completely detailed and on point here, what we actually mean is that omega is contained inside the set of omegas for which an multiplied by x of omega goes towards 0. And this set is also what we normally just denote by using event notation, an multiplied by x goes towards 0. So this actually means that the entire set of all outcomes is included inside this event. Now, since any event must be a subset of omega, since by definition any event must be a subset of, the total amount of outcomes that the events can happen on, then we have that the inclusion goes both ways, and we can conclude that omega is equal to anx going to 0, so that these two events are similar. So even though it made good sense just to say it, it's also very nice to write this down, because this is normally how things go. We normally say, well, if omega lying inside the event A implies that omega lies inside the event B, well, then that naturally means that A is an event that is contained inside B, and normally that will also mean that the probability of A is smaller than the probability of B. And this is a very useful kind of tool that we can use to move things around. So that was a nice tool for you guys that you can use, the relation between implications and subsets that we use a lot when we do probability calculations.